kembali kembali ke tell you, ya, Mas Gilang waktu itu
Mantap.
sudah kembali. Oke, sebagai info Mas Gilang, ini kelasnya kelas bahasa Inggris Mas Gilang.
Oke,
Jadi
oke.
nanti Gilang bisa present in English ya. Mungkin kita mulai ya, saya buka dulu ya. Terima kasih ya. Eh, Baik, good morning everyone. So this is Pak Gilang Bhagaskara. Pak Gilang is uh, one of the old player in a blockchain met maybe 2 years ago, maybe before that. I remember he talked in blockchain area, like I remember Blocksphere or something like that. You have also social media, right? Social media, decentralized social media. I don't remember the name.
Myriad.
One of decentralized social media. Ah, Myriad. Yeah, yeah. You teach us how decentralized social media works. I think it was offline session yeah in Telkom University is quite
Yes.
impressive because after that we have several research decentralized social media, and I think it might not be popular right now, but I think it will be later. Yeah, it will be good, will be popular later. So today, Pak Gilang will be share to all of us about smart contract and Ethereum. I think if you can show up your face, I uh, I want you to show up ya. So Pak Gilang will see with you ya. Okay. Uh, so I can also photo ya the class, so I know who comes to the class and who cannot attend the class. Okay, okay, I will give the stage to Pak Gilang. Before that, sorry Pak Gilang ya, nanti saya mungkin duluan ini ya karena harus mengejar bus. Nanti mungkin ada di sini
Siap.
namanya ketua kelas Saskia. Will you show up your face, Saskia? Ah, dari Saskia. Saskia will lead after I'm going. Ya, so feel free everyone to ask the question to Pak Gilang later. Ya, silakan Pak Gilang, your place.
Okay. All right. Thank you very much, Pa Andri. It's been a while. It's been always an honor to be able to share with your students, Pa Andri. I see that your students are very enthusiastic, and I think sharing about this topic, especially about something that I think is more about new technology that is very exciting. I hope that this is going to be something that's going to be useful, and you'll have very engaging students and students who are, you know, more eager to explore about blockchain technology. So before I start, I believe that you have seen my screen. This I already prepared something that I think you can just scan the QR code, and then if you have any question, you can just access the website. You can just send any
So,
question my way through that mobile app. It is going to be available here before I share my screen to talk about my topic. All right. I hope that everyone has already shared the. I hope everyone has already opened the website. So I think I'll just share the other one here. Okay. Yeah. Okay, you guys can see my screen now. All right.
yes, yes,
So okay. So the topic right now is about Ethereum and smart contracts. So hopefully that after the session, you guys will be able to understand more about this technology, more about blockchain technology, and also going to be about Ethereum, one of the implementation of blockchain in the public, and also how to develop on top of Ethereum using a concept that we call a smart contract. But before, yeah, this is the table of contents. But yeah, I was told that this is going to be an full English presentation, but bear with me. I have Indonesian slides, so I think it's not going to matter because you guys are should be able to understand my topic because I'm going to deliver it in English. But before that, I need to introduce myself. So, my name is Gilang Bhagaskara. Currently, I'm the CTO at one of the crypto exchanges in Indonesia. We are already registered and already submitted to Bapepti and in progress to have the license, full license to operate in Indonesia. And currently, I'm also the CEO and CTO of Blocksphere Technology Indonesia, which is a blockchain consulting and development firm. And we already have multiple projects spanning from government, enterprise, and also startups and Web3 global projects as well. And yeah, my passion is actually to build, advanced blockchain programs and also have a lot of blockchain um, sort of like evangelism and telling people how to develop on top of blockchain and so on and so forth. So um, previously I took my degrees in computer science both in Universitas Indonesia for my bachelor and master degree, and I'm also a certified blockchain professional by EC Council. All right. But before I want to talk about Ethereum and smart contract, first of all, I think we need to talk about uh the main, the blockchain and blockchain itself. If if you are already familiar with something that is called ledger, or something that is called the sort of like a big book for accounting, blockchain is basically something that simulates or that replicates that concept into a digital world, and then make sure that that data is being distributed all across the network that helps verify the data itself. So it is in a sense like a big book, which is distributed. It is digital, and also something that you write on inside the book is going to be permanent, and you can change it. And then once it is written, it is going to be immediately replicated to everyone who owns that book, and then everyone who owns that book also helps verify the authenticity, and also helps verify that the data inside the book is valid. And then once it is already written there, you cannot remove it, you cannot erase it. Or if you want to make a change, make something that's you made a mistake on like certain page or maybe somewhere inside the book, you cannot just modify that page because all the content inside that book is going to be replicated in every book holder. And if you change a data in one node, or we call it a node, you will need to change the data at everyone else's book. And then there's also something that is called encryption, which is an encryption means that all the data inside that book um, it's being made like more complex because we use the sort of like uh, it's I'm sure that you guys are already more familiar with encryption. So I was going to make like a more layman terms of how encryption works, but basically we make sure that the data becomes a secret, and then once the data becomes a secret, and it's going to be added with the newer data, so that all the data eventually all the data well. So if you change a data or maybe an information from back, like let's say from the block 100 that is already from like a couple years ago, all the information that gets written in the book or in the blockchain will need to be modified until the current block, and it is going to be a very tedious activity to change that information. Not only it is very difficult to change that information, it is also going to be very time consuming because you need to change all the data that is already being stored in everyone's book. Actually, this concept itself came in 2009, where back then a group of people, or maybe someone who calls themselves Satoshi Nakamoto, created the network that is called Bitcoin. And Bitcoin itself is actually a network that he made so that this there is an asset that is called Bitcoin on top of the network, on top of the Bitcoin network itself. And this concept this person made so that Bitcoin itself is not going to be centralized or centrally minted or centrally controlled, and make sure that this network is self-governing and also self-securing. And everyone inside this network also helps verify and also helps make sure that the network runs well and also is secure. And if you already since this is a novel concept back in 2009, people who speculated in 2009 with the asset that is called Bitcoin, it's already holds Bitcoin or mint Bitcoin from that moment, from that era. They started trading this asset, and also once they traded this asset, there came the supply and demand, because this asset already changes how financial world works in from back then. And since this is not centrally controlled, this was going to be purely based on the supply and demand for the value. In this lecture, I think we need to address the concept of cryptocurrency, because cryptocurrency is also something that is very tightly related to blockchain, and it is one of the use cases that is very popular and also very successful. In, yeah, currency when it comes to blockchain, because sometimes I find some people who says that I'm more into the technology, I'm more into how the central decentralization and also encryption and so on and so forth, how it works, but I'm not going to talk about cryptocurrency. I think that's not a good mindset to have. I think we need to also embrace the concept of cryptocurrency, because because cryptocurrency was and is still one of the biggest use case of blockchain. Uh, there are a lot of other blockchain networks or concepts that stems from this concept of Bitcoin. It used to only store, Bitcoin and also Bitcoin related networks used to only store information of basically transactions, whereby a transaction can only have a couple information, such as who's sending the transaction and who's receiving the transaction, and when or what is the timestamp of the transaction when it happened, and also the value of the transaction, like how much is being sent and being received. But along the way, people started to create like more advanced concept on top of blockchain network, and then it allows people to have more flexibility, such as making sure that this transaction triggers something that changes the state of the block inside the blockchain, so that it becomes possible, so that people who wants to create storage or maybe create logic inside the blockchain. When you trigger the transaction, this transaction is going to trigger the change of a state inside the block or the blockchain, and also triggers the logic inside the blockchain. That is going to be called smart contract later on, but we'll talk about smart contract later. In 2009, that was the first Bitcoin Genesis block that was generated, and this Genesis block was also the place where the Genesis state began, and inside this Genesis state, it captures the current state of the block, such as who's holding how much Bitcoin inside inside the current block. And then along the way, this block is being added and being linked into the previous block. And then also the state of the block is also going to be updated as well. And then cryptographically, all this block is being linked from one to another. And then every time one block is being linked, it is going to bring the previous cryptography encryption so that whenever a new block is being created, it's always going to link to the previous block and to the previous block and up until the first block. And since this is public, it is possible to see and also to verify all the data inside the block. And historically, it's going to be possible for us to see all the information from the earliest block up until the newest block. Well, the next part I want to talk about is how the block is being verified and how the block is being validated and how to select the new block to be added into the blockchain. Remember previously I mentioned about the big book, and also this book is being verified by a lot of people who also owns the book. That's the concept of consensus. This concept of consensus inside the blockchain is very crucial because consensus means that the data that is being added into the block, the new block that is being added to the blockchain, needs to first be verified by at least consensus inside the network. The type of the consensus itself is going to be different from a lot of blockchains. From one, let's that is the way that the data is being verified by making sure that the verification happens with 50% plus participants inside the network, which is something that's also possible when we talk about consensus. Um, and how to make sure that this concept is viable or usable inside the blockchain, or maybe inside the distributed network. There are a couple of ways to allow these machines to talk with each other and have the verification happen with these machines that's joined inside this blockchain network. One of them is by making a consensus algorithm. A consensus algorithm is basically an algorithm that allows these machines to go through a process of verification, whereby this process of verification, when they have already this kind of incentive allows people who wants to join this blockchain network to feel motivated, to make sure that people who joins this blockchain network see that there is a benefit of joining, because at least they get an um, basically any kind of incentive that this blockchain network offers according to the consensus algorithm that they have in the network. There are a couple of consensus mechanisms here, and consensus algorithm itself. The first one that used to be very popular because it is one of the earliest one that's being used by Bitcoin network. It is called the proof of work. Proof of work is basically an algorithm that requires the participants of a network who wants to validate a data that is going to be generated and put inside this blockchain to be validated by making sure that this computer does some encryption work, some hashing work that requires computing power from these validators. So when these validators spends their computing power, they will spend resources, definitely, where these resources can be electricity, and also these resources can be computing power, that's going to require several specification that first you need to purchase, and also you need to procure that kind of device that can do this kind of work. And then also internet connection, it's going to need require you to be able to be connected 24/7 And this kind of activity is very resource consuming, and it's um not a lot of people are able to do proof of work algorithm verification. And as far as I understand, it's going to cost you very, a large amount of money, um, probably in the amount of like 100 million rupiah, or maybe up to billions of rupiah, to be able to set up a proper mining farm that allows you to generate, cryptocurrency from your farm. And the downside also from proof of work is because it's very it consumes a lot of resources. This activity is also not very good for the environment. Um, I think I can show you later the data of how big this how big this impact for the environment uh, based blockchain network, um, in comparison to several countries' electricity usage. And I think it's already in the top 20 of electricity usage all across the world. So some blockchains started to move and already implemented other consensus mechanism. Like for example, previously Ethereum is also a blockchain network that uses proof of work, but I putting something at stake. Let's put it simply, putting something at stake. That is called staking. What is at stake? Something that's at stake is actually something that we are you know we don't want it to lose, so that it makes sure that we will if this if something that is put at stake is is then later if we put something at stake, it means that if we lose it, it's going to be very difficult for us. It's not desirable for us. So what is at stake in this proof of stake consensus mechanism in Ethereum? What is put at stake is actually the asset itself. The asset itself is the Ethereum, the Ether token that is on blockchain network. And the amount of Ether that is required for us to join this proof of stake is 32 Ether, 32 Ether. And if we current price of Ether is going to be more than 1 billion rupiah, I think, to join this proof of stake. So by making sure by moving to proof of stake, we make sure that we don't spend too much computing power, so that we in terms of computing power is obviously going to be a lot cheaper by not making these validators work very hard and spend their computing power. And then it also in a way it also encourage people to have to be basically uh to be truthful basically, and not making fraud inside their by doing fraud validation, because something is at stake. They can anytime lose the Ethereum that is already at stake there. um the other concept that we need to learn is also decentralization. So why do we decentralize this data? Why do we distribute this information publicly? So this is actually an antithesis, or maybe something like a paradox where if you want to secure an information, you share this information to as many people as possible. So the way that this information is being shared is it's being encrypted. People who owns your information will not be able to work with that information unless they have the authority to move or to modify that information. There are a couple benefits of working, of storing this information in a decentralized manner. For example, we see that the negatives of a centralized party, such as the data hacking and also breach, and also the other one is if you are already familiar with how social media works, such as Facebook and Google, they have the authority to modify and also to control your data and also basically to censor your activities. And in terms of us owning our data, it's going to also limit our freedom, and we are going to be more sort of like dependent on this central authority. Maybe you have already heard about a couple of times that that some data centers or maybe cloud infrastructures that is down, and it affects a lot of people all around the world. That's something that is caused by centralized network. And on the other hand, the benefits of decentralization is that first of all, there is no censorship, there is no central authority that can basically limit your movement, and also there is no downtime because your information, your data is already being stored by hundreds or if not thousands of nodes or on network participants all around the world. And the also the one of the biggest benefit is it's very difficult to attack because if you change the data from basically in one node, you need to also change the data of all of the nodes, all of the participants inside the network. Now, the next concept that I want to talk about is Web3, which is I think already quite popular in the recent years because Web3 is seen as something that is novelty. It's something that's something it's seen as something that's very different from the current web Web 2 that we already have right now. But first, we need to talk about the phases. Why do we call it Web 3? First of all, we know that the first iteration of network information in the internet, um, a lot of things is just one way because this basically just online brochures that if you access the internet, you'll be able to see information, but you are not able to interact with the information. You're able to see some graphics, some news, and also maybe music. I don't know about video, but it was not a concept yet that you can have your content uploaded inside the internet back then. Now, the next concept is Web 2, which is basically the evolution of how people use the internet and how people can interact with the content inside the internet. Uh, this is already something that is very normal, already something that is very common here. All around the world, people are already using applications, websites, and social media, and also all the contents that you can just access from your fingertips on your smartphone uh, through applications and also through mobile browsers, and people can interact from all across the world. But the downside of this Web 2 is that we somehow we subconsciously or maybe consciously um give our basically our data, our consent, and also our freedom to these application providers. For example, if you are in a social media, if you are in an active user of of a Web2 product, for example, like Facebook or Twitter, or right now people are more towards Instagram and TikTok. All our information is being stored inside their servers and inside their premises, and they are able to basically do anything that they want with our information. And it means that we have less privacy, we have less control, and they have the most power to have now that's how the concept of Web3 come along, where Web3 allows the internet to also have some previously actually people want to have this kind of control and self-sovereignty of their data
Apa itu
in the
Web3?
first in the first iteration of internet. Yeah, sorry. So in the first iteration of internet, like previously, when the internet was being being delivered to the world, that's idea. All data should be self-sovereign, or be able to govern their information, their privacy, and their data. But through Web 2, through the eras, people started to see that data can become sort of like a gold mine. So they want to have all the data, all the information to be stored in their server, in their premises. And Web3 wants to bring back the first concept where decentralization and also permissions, trust is being restored back to the owner of the data. And how this concept works is by leveraging the concept of blockchain, which is decentralized, distributed, open. It doesn't require trust or trustless. You just need to trust the code, and also it is permissionless. So a lot of application, a lot of websites are already moving or embracing the concept of Web3, and we will see some examples later in this lecture. So one of the blockchain networks that I have already mentioned several times, and it's also the title of this lecture, is Ethereum. And I want to talk about Ethereum in short. So when we talk about how smart contracts, how blockchain can revolutionize the web and also allow people to be more decentralized and permission and have full control of their data, one of, if not the first mover of this concept is a blockchain network that is called Ethereum. Ethereum 2015, I believe, by Vitalik Buterin and their team, where people who wants to build decentralized applications on top of Ethereum is, they can just create this kind of application because Ethereum has their own sort of like virtual machine. And then the global state of Ethereum is not only storing the balance or storing the information of how much Ether that people have, but also all the decentralized applications that people build on top of Ethereum. You can call this kind of concept sort of like a world computer, where everyone who builds an application from one, from anywhere in the world, whenever they deploy it into Ethereum, this application will be live all across the world and will be accessible by everyone all over the world. And you build decentralized application by creating smart contract, and smart contract is built by using a programming language that is called Solidity. And actually there are a couple of other programming languages that you can use to develop smart contracts. on top of Ethereum. But later in this lecture, we are going to talk a little bit about Solidity and how we develop the smart contract. Like I've already mentioned earlier, Ethereum is now using a consensus mechanism that is called proof of stake. It used to run on proof of work, but from 2022, Ethereum has moved into proof of stake to make sure that this network is more sustainable and it is more environmentally friendly. Ethereum was created by Vitalik Buterin. He used to be, he was a young programmer who works with Bitcoin magazine. I believe he was also the founder of it, and he used to write some technology piece in this Bitcoin magazine, and in 2011, he moved full time into the crypto world. And then some of the concept that he and the early founders of Ethereum had was to to see whether this blockchain concept, where it used to be only Bitcoin, some other Bitcoin based blockchain networks back then, they don't have more capabilities other than just storing values and also transaction of basically um, coins that is operating on top of the network. Uh, he pitched this idea to a lot of to a lot of existing projects, but after a lot of rejections, he decided to do it himself, and also he introduces the concept of fully programmable blockchain that is Turing complete. Turing complete is something that basically it passes the Turing test, where um, you can create anything by making subject inside the piece of program. And this concept later on becomes Ethereum. And in 2014, this project was publicly announced by the core team that was led by Vitalik Buterin himself and several other people. Okay, so this is some of the basics of Ethereum. Like other blockchain networks, Ethereum has their own uh, currency, or what we call token, on top of the blockchain network, or in short, ETH, and it is still available up until now, and people can already trade Ethereum in major cryptocurrency exchanges, or mine Ethereum using validators and then store it in their crypto wallet and do anything that they want to do with this token. And then there's also the concept of smart contract. Smart contract is basically a small computer program that you create and you build and deploy it in the Ethereum network. And then once it is deployed in the Ethereum network, it will be replicated in all of computers that is connected to this that Ethereum network, and it will live in one of the blocks that is generated. It will be put in the newly generated block. And then once this smart contract is already live inside this block, it will be able to update it, in terms of, I mean, not the code is being updated, but the state is being updated from subsequent blocks. And if we interact with that smart contract, this interaction will modify the state of the smart contract. So this concept allows people to create any kind of application that you build on top of the smart contract. But the way that uh, keeps smart contract safe, or maybe make sure that smart contract is not being abused by people, because if you interact with smart contract, it is also considered as a transaction. And uh, if you do a transaction inside this blockchain network, inside this Ethereum network, you need to pay for the transaction. There is a transaction fee. The transaction fee that you pay in this Ethereum network is using the Ether token. And an Ether token, the cost of executing a transaction of inside a smart contract, it will depend of how complex the transaction is, and also how difficult the current uh you know how big is the difficulty of creating a transaction inside a block right now. So those are the factors that makes smart contracts safe, as and you know basically not being able to be abused by by people. Also, some of the use cases on top of Ether that is very popular is called token. Token is basically standards that the programmer of the blockchain that they created to make sure that it will be usable all across the that this concept uh, is enough to store information of how the currency and value exchange happens inside the network. We have several kinds of token standards here, but I'm going to talk about ERC20 token, which is called a fungible token. Fungible token is a concept where if you trade a certain amount of token or a certain value, you don't need to worry whether this value is using, basically, if I wanna send money to Pak Andri here, let's say, for example, 100,000 rupiah. This 100,000 rupiah, Pak Andri will not care if I give him with two pieces of 50,000 rupiah, or using 10 pieces of 10,000 rupiah, or just one piece of 100,000 rupiah. What he knows is that he will receive 100,000 rupiah. So that is the concept of fungible. Um, this concept is also is the concept that is being used for the generation of a lot of tokens that is created on top of Ethereum network, which is the ERC20 token. This is called the ERC20 because there is a concept, basically there is a procedure that if you want to build or you want to create an improvement inside the Ethereum network, you will need to first submit a proposal to the as a pull request in their GitHub, and then this proposal will later on be reviewed by the foundation and also by the community. And if it passes, it will later be put inside the platform as as an agreed upon release candidate um, improvement for the network. And this ERC20 token was one of the proposals, and one of the earliest proposals, because I believe right now ERC is already at the more than 5,000 ERCs already. And the other uh the other token that is also worth talking about is 721 and ERC1155 token. ERC721 and ERC1155 is actually token that represents non-fungible token, which is basically the other um, like 180-degree difference from the ERC20 token. Basically, ERC721 and ERC1155 allows the concept of non-fungible token, where non-fungibility means that um, if you receive an object, you will see that the object has attributes. This object will be comparable from one another, and this is going to be distinguishable. For example, you receive let's say a laptop. This laptop has specifications. It has RAM, it has storage, and it also Mm, if you compare one, this is going to be you will need to um yeah, you will not want your laptop to be compared, or maybe to be traded to a laptop that has less specifications from your laptop. And such, this kind of concept allows people to have valuation, or have you know different appreciation of the object. And this concept allows people to also replicate the sort of like physical concepts of object into a digital object. That's why there is a market for this kind of concept, and it is very big in the art market, because artwork, people were able to have valuation and appreciation of different artwork to another, and it is represented on the blockchain network with the ERC7 and ERC1155 token. So network is through a crypto wallet. Before we understand about crypto wallet, we first need to understand the concept of address. Address basically is something that identifies our control and our access into the blockchain network. There are two kinds of address in Ethereum. The first one is externally owned account, and the other one is a smart contract. The externally owned account is something that we can control, and smart contract is something that lives blockchain. It has its own address, so that we can see which smart contract that we are referring to when if we have a blockchain address, we can freely give this address to anyone, and anyone who wants to interact with us and want a transaction can use this address to verify actually an address that I own. Now, how do we control this address is through private key. Private key is the pair of for this address that is supposed to be kept a secret. It is similar to like a password, a very strong password. It's combination of words and letters. But you cannot share this information to anyone, because once someone has an access to your private key, they will be able to access the assets inside your address, and they can impersonate you as the owner of this address, and then basically move any kind of asset that you have, interact with any kind of smart contract that is maybe you don't want to interact with, and basically steal all your assets from your address, and you cannot do anything about it if you lose your private key, or somehow expose your private key to the world. Now, there is also a concept that is called seed phrase, which is similar to like password, but seed phrase is basically a 12-letter sentence, a 12-word sentence. Um, it is um you know you cannot make sense of this because of words. And if you add this information to a crypto wallet, you will be able to create or recover the information because there is an algorithm that changes or basically uses these words as a seed to generate as many crypto addresses as possible. So when you create a crypto wallet, you will be asked to provide a seed phrase. I mean, they will provide you seed phrase, and you will be asked to store this seed phrase securely so that it can become your backup in a time that you lose your private key and you want maybe to change devices to another one. So what is a crypto wallet? So crypto wallet is basically it can be an application, it can be a physical one, but it is used to basically manage your accounts, especially all the private key inside your account. It also allows you to interact with all kinds of decentralized applications, and it allows you to access all the anything that Web3 requires you to sign in, and it's very convenient. It already available in I believe in Android and iOS, several cryptocurrency wallets, and some of the most popular ones is MetaMask and Coinbase wallet. So this is the screenshot of MetaMask, and later I will show you how in the demo of how we interact with with basically with this MetaMask and send a transaction and check the transaction happens in the network. Now, I want to talk about smart contract and how do we create a smart contract. So basically, smart contract is a digital program. It runs automatically on top of blockchain without without the need of a third party to run the smart contract. We create the smart contract by developing the code, and this code will basically we will make that code do any kind of logic that we want. We can just create a simple from like a simple data storage into a much more complex decentralized finance for swapping two different kinds of tokens, and also create a bonding curve to make sure the liquidity of tokens from a decentralized market to have a stable price and so on and so forth. To create a smart contract, we use a programming language that is called Solidity on top of this Ethereum network. And once we develop the Solidity code, we will need to first test it in the local environment. And then after we test in a local environment, we will deploy it to the blockchain. And also, once it is already deployed in the blockchain, we will be able to smart contract. Step by step create a smart contract. First, you need to create a smart contract code using Solidity programming language. You can use any kind of framework. There are a couple of frameworks that's available like Remix, Truffle, or Hardhat. Later we will see how to develop smart contract on Remix. And then after you test it in the local environment, you deploy it. And if you do a deployment to the blockchain, make sure that you deploy it first to the testnet so that you will not be charged an actual transaction fee. You can basically use this testnet by by deploying it using testnet Ether, which has no value, and you can just receive this testnet Ether anytime you want from a lot of testnet faucet. It is called faucet because it's similar to a faucet in a way that you can just open the faucet to receive this testnet Ether. And then once you are ready to move into production, you can just deploy it to blockchain the way that you deploy it to the um, and once you have already deployed the smart contract, you will be able to see that the smart contract is live on a certain address, and also the smart contract has all the documentation, not document. a binary interface. It's basically an interface that allows you to create your web application using your favorite programming language, such as JavaScript or maybe using C Sharp or whatever, to interact with your smart. Example of IDE that can basically that allows you to create a smart contract by coding directly in this in the web browser and deploy it uh, directly to a blockchain using your web browser from this environment. All right. Since this is basically the end of my seminar, I will move on to I'm moving on to show you guys of how smart contract works and how to develop smart contract. But before that, if you have any question, just type it in the chat, or if you want to use the Slido that I've already shared before, I'm going to share it again here. You can just scan the QR code and talk with, submit your questions there. Okay. Okay. All right. So before we dive into the concept that is blockchain explorer. This is tool to and the content of blockchain and basically search for any kind of transaction that happens in Ethereum blockchain. This website is called Etherscan. I'm going to zoom in. Uh, this is a this is a website that allows you to see all the information inside the block, and it has all kinds of the most recent information, such as the price, the current number of transactions, the current block, and any kind of market related stuff, and also the I will show you the content of a blog here. No, this one is already 1 hour ago. All right. Yeah. Um, I will open the previous blog. Okay, so this is the content of a blog. Basically, all the information that is stored in the recent blockchain state is stored in this blog. I'll break down. First, we have the block height. The block height means the numbering system that this Ethereum blockchain has to identify is being generated on the blockchain. And with the block height of 20 million 900 something, you can see that this block height has all the this block has all information inside it. For example, the timestamp of when the block was generated, which is 37 seconds ago. It was proposed here on the slot and the epoch, and the number of transaction that happens inside the block, and the number of contract internal transactions in this block. And this is also withdrawal that is related to staking here. There are 16 withdrawals in this block. And who's the miner, or basically the node that receives the fee for the block. Now, every time a block is generated, it will have a reward, whereby this reward it comprises, first of all, the static block reward is already 0, and also the transaction fees that covers all the transaction, the 180 transactions here. And then there's also the burnt fees, the fees that that make sure that the Ether is burnt because after moving to proof of stake, Ether is now deflationary in a sense that the amount of Ether in circulation is not going to be too much and is already being burnt by from each block. And this is the total difficulty. I believe difficulty is related to how difficult uh, to generate the block up until the current one, and it's already calculated from the very first block. And this is the size of the block, which is 66K. And yeah, I think I need to have someone to help mute some participants. Okay, the next one is the gas used, which is this is a limit of uh how much activities or how many actions that can be spent on this block, and it is capped at 30 million. But the actual gas that is used to facilitate all the transactions is only 14 million, which is about 48% of the total gas limit that is allowed in this block. And then the base fees for the gas is at 9.64 GUI. GUI is basically uh, you can see that this is 0.00 up to 8 leading zeros. And then that is the smaller amount of ether that is being used as the notation to pay the gas in the Ethereum network. And this is the burnt fees, basically the fee that is being burnt. And if you see the extra data here, you will be able to see the hash of the block, where this hash of the block, it also contains the parent hash, which I believe if we click on this one, it will be the same as clicking on the previous block here. So just which this one is also the button. It is being accessed through the block hash, and the other one is accessed through the block height. An information next, it ties both blocks so that it will ensure the information is not tampered because you will have a different hash if uh if you modify the information of the parent hash, I mean of the parent block. It will have a different parent hash, so it will not be able to link to this current block. So that's the anatomy of a block, and this basically the concept of a transaction, where I've already mentioned earlier that a transaction should have the time where the transaction happened, the sender of the transaction, the receiver of the transaction, and the value of the transaction being transacted in the inside. But since this is Ethereum, there are a couple other stuff that happens where not only the transaction allows transferring of asset, it also has other functions here, where these other functions are basically smart contract functions. There are a couple other functions here, not only just transfer, but also claim, execute, queue withdrawals, deposit, buy, swap, and so on and so forth. But for example, let's just open one of the uh, let's just open one of the transactions here. There is a transaction for 0.025 ETH. I'll just open this transaction hash and I'll be able to see all the information inside this transaction. Where this transaction is being stored is on this block where we've already seen, and it was executed 7 minutes ago. About a transaction about sending 0.025 ETH from the sender. This one is the sender, and this one is the receiver. And this transaction uh, costs the sender, where if it is converted to US dollar, it is 0.54 US dollars. And there's also the information about the gas limit fees and also the burn fees and other stuff. And you can also input the data inside the transaction. Now, there's also the contract transaction, such as this one, is executing a contract. What does the transaction do? There is there is someone that is crypto. We'll talk about ENS some other time, but this is a transaction of swapping Ethereum for L3. I'm not sure what this is, but I believe this is a token that is called Layer 3 on Uniswap. Uniswap is one of a decentralized application. And this contract, uh, basically it does several stuff here, from changing, from calling a Uniswap smart contract. And then this contract also it also triggers this contract, triggers other stuff, and eventually returns back the amount of layer 3 token back to the crypto voice, because what he wants to do is swapping this amount of ether into this amount of L3 token. So that's an example of a smart contract interaction that you can see in this blockchain explorer. Now there is also the concept of account that I think I want to open it here. This is an example of an account. You cannot uh, basically you cannot see any kind of identifiable information from this. You'll only be able to see addresses, you'll only be able to see hash, but this is already like an active transaction, and you will be about and how much ERC20 tokens that they have, and the amount of transaction that I mean the number of transaction that they have, and the latest and the first transaction that they have, and who sent the first transaction into this account. And I believe they have some other portfolio, or actually no, they only have an Ethereum portfolio here. Okay, that's the concept of Block Explorer, where I think it is a very useful tool for you to explore, and also the uh, basically everything inside the blockchain. Now there is also something that we call MetaMask. MetaMask is basically a wallet that allows us to store all kinds of blockchain, I mean tokens. So before we want to interact with the basically with the network, um, it's very easy. You just need to download a Chrome extension, or maybe you just need to download it on your mobile device, on Android or iOS. And there are also other options other than MetaMask, but I'm just going to show you that this wallet, you can have sending and receiving kind of token and all there. And the transaction here, you just click send, and then you'll be able to put a public address here. For example, this is another account that I have, and you'll be able to send Ether here. And then if you click continue, it will calculate the gas that is required to send this transaction, which is currently is quite cheap for sending a transaction of 0.01 Ether. It costs me like 0.5 dollars, and it will be executed in 60 seconds. I'm going to end this transaction. I'm just going to reject this, but when the transaction happens, it will be visible here. Like this one is going to open the block explorer that we have already seen before, where in 2023 I used to have a 0.02 Ether transaction into the wallet. Now, we talk about the concept of Solidity smart contract and how we develop smart contract on Remix. Because Remix is one of the easiest tool that we can have. We can also actually use Visual Studio Code or everything that we are familiar with. But Remix is an online free-to-use tool that is already quite robust. It has a lot of templates here that you can just create and immediately deploy to the blockchain network. And it is already compatible with the any kind of crypto wallet. I think it's also compatible with MetaMask and other stuff. Now, you want to do to create a Solidity blockchain project, a smart contract using Solidity programming language, is to create a new workspace here. There is an option here, create using template, and it will open this page where you can select any kind of template here. There are going to be a lot of projects for you to choose. ERC20, a simple fungible token contract, ERC721, ERC1115, multi-token contract, and there are others using the library that is called Open Zeppelin. This one is basically similar to the first one, but this is using proxy. It's quite an advanced topic, but I'm not going to just use the concept in here. There are other projects such as token sale, simple NFT sale, ERC721A NFT sale. This is a concept that is the derivative of ERC721 that was introduced by the Azuki project. And then there's also the soulbound NFT, no transfer capability of the NFT, and then there's also the basic DAO, decentralized autonomous organization, and everything else. I suggest that everyone creates any kind of project in Remix because for money, you can just test it and also deploy it on your local environment. Or if you wanna deploy it on a testnet, you can just find a faucet somewhere and then request some testnet tokens, and you'll be able to deploy your smart contract on the testnet environment. So right now, I'm just going to create an ERC20 token here in a new workspace. Tell you token. And yeah, this is already generated by Remix, and we can already basically, yeah, it will first populate any library that they need. And then if you want to do a deployment here, let's say, for example, tell you token. I'll change the name into tell you token here. And then I will rename this tell you token. All right. The good thing is that it immediately builds your contract, and then if you once Remix has already built your contract, you will be able to see it here. I'm just going to quickly fold the dependencies here. Now there are a couple stuff here that happens. There are deployment scripts here. There is a test script, and then there's also, I'm just going to change this value token. Okay. Okay, part, but I'm just going to share with you that it's possible for us to do the testing here by making an assertion for any kind of variables inside the token, I mean inside the smart contract, so that we can check whether the value is correct or not. Now this is the basic ERC20 token, and if we wanna compile it, it will compile it using the latest uh, I believe this one is the stable. Yeah, it's the local one and the most stable. If we open this and then we click compile, it will compile the token and it will compile the smart contract. And this one means that the compilation has already been successful. And compiling the contract does not mean that the contract is already live on the blockchain. This is still inside our PC, and if we want to deploy it to the blockchain, we will need to deploy it first using a deployment script. But here we have two information that we can use later if we want to connect our smart contract to our website. For example, here I want to click on the ABI and then I'll open a notepad here. This is the ABI. This is basically an interface for us to connect to our smart contract. And then the smart contract will also have its own bytecode, but this blockchain. It's also available here in the token as well as the ABI and also the bytecode. Oh yeah, by the way, ABI stands for Application Binary Interface, right? This one is the object that is too long for us to comprehend. It's not, yeah, it's not useful for us anyway. So here we already have our token compiled, but if you want to deploy and run the transaction, we need to click on this deploy and run transactions. There are a couple other stuff here that you can choose, but this one is for deploying and running a transaction. And the good thing about Remix is that it already has some deployment targets, such as this is a basic um, local environment that they already have, which is the Remix VM. They call it Cancan. And then there's also the mainnet fork for the Remix VM. And there are other stuff that you can connect to. Like, for example, this one is the injected provider, which means that the current active wallet that I have, which is MetaMask, this one is currently the active one, which is using this address that I have shown you earlier. But yeah, the other ones, you can create a connection to an external HTTP provider. Let's say you want to have you want it to connect to a node or whatever. And also there's a connection to any kind of framework such as Hard Hat or Foundry. Now we'll need
Oh, udah
to,
di screenshot ya, udah aja lah.
I'm gonna need to have
Keluar aja kan?
someone to mute the participant. Thank you very much. Okay. Uh, we'll just stick with Kanken here. They already provided us with a lot of accounts, and this account already is supplied with a lot of Ether. And then you can just deploy this contract into a local environment. And this one is, I think this one is not, yeah, this one is the correct one, the tell you token. And if you click deploy, it will be deployed in the blockchain. This is already, actually, this is already deployed. You can see the address here. The address is this one. And I believe this account already has spent the the contract, and yeah, it's reflected here. It's already been deployed. Because we deploy the token here. There are a couple functions. Maybe you want to call the name here. If you call the name, it it will return as tell you token. If you call the symbol, it will return as the tell you symbol. Since we don't have other information such as the total supply and so on and so forth, we don't have that information here. It's still zero. There is no other stuff here. Only the decimal length here. See length. Now, this is a very basic token deployment, but I think I'm going to show you something else using a different template. Mintable, burnable. Oh, this one is simple, fungible. This one is mintable. I'll create a new one. Burnable. Oh, sorry. Mintable. All right. This one is similar to the previous one, but the difference is that we can actually mint the token. Minting means that we can basically add some token to the account. I'll just use the my token here, MTK, and it's already being compiled. Well, I just need to create a new workspace. No. And this one is the environment. So I'm just going to compile this first, the my token contract. All right, this one is already compiled, and we can already deploy the contract here, this my token contract. And we'll need to add the initial owner, and we'll copy the account as the initial owner, and we deploy it. Now it is already deployed. And after deploying the contract, we'll see the owner here is this same account. And then we'll be able to mint the account, some token. And then this one is the amount, for example. Click transact here. This is already a transaction in the blockchain network. It's already a function call. And then if we see the balance of the account here. It's already available here. There you go. You'll be able to see the amount of token that this account has. And let's say we want to share, we want to send a token to someone else. We copy this account from this one. We transfer some token here. And we transact. After we transact, we call the balance here. It's already been reduced. And we see the balance of the other account has already been added here. 1, 2, 3, 4, 5. Now this one is still very low level and just very, not user-friendly interaction for, to interact with the smart contract. But we can actually add those token here. Import token, basically you can just create it here. And then if you already imported your token, you'll be able to use MetaMask to similarly do the sending and receiving using this interface. And it's going to be very user friendly. It's going to be similar to the process that we had earlier. Okay, so that's the basic of Reem. And what about some other stuff? Blockchain networks such as creating a token or maybe swapping a token and do basically connect with any kind of smart contract decentralized application. Uh, Another decentralized application that is called Pancake Swap. Pancake Swap is a decentralized finance platform um, that allows you to swap your token from one token to another. And I'm going to just use I'm going to use my account here. Hopefully it's not going to take too long. All right. Okay. Yep. I believe there's a connection issue, but this is going to be the user interface of how we interact with Pancake Swap. You can wallet here. This one is connected to my MetaMask, and then you will be able to see your Ether balance or your account balance here, and then swap your token to another token inside the platform. Now, there is also OpenSea, which is an NFT marketplace where you can send or receive or buy and sell NFTs. And some of the NFTs here are for sale for whatever price that they want to put inside the platform. There are other decentralized applications that you can explore. And one of the two you can DappRadar here. DappRadar, it will list down all of the most recent and the most popular decentralized applications so that you will be able to see and interact with everything that's using Web3 here. And not only for creating basically for token related or cryptocurrency related um, smart contract or decentralized applications. This is actually a project that I do with Myriad Social, which is a decent media, it's leveraging NFTs and also tokens to allow people to send tip to someone who posts in the social media, and also to immortalize your post into an NFT, um, so that it will be able to, basically for some transaction or maybe some post that is important to be put and to be immortalized in the blockchain platform. And this is already using the both decentralization and also the federation concepts, and allows people to host your own social media, and without the fear of censorship and all, and third party owner of your data. Okay, basically the lecture for today, and I'm going to see the questions that we already have here. Um, We have a question from Saskia. If our blockchain is hijacked and we forgot our private key, and can we recover our account by hijacking the chain? Uh, First, I need to clarify hijacking the chain. Here, it is actually not possible to hijack, in a sense that we want to modify the state of the chain by changing anything that is already put inside the chain engine, and then we recovered our assets by modifying the information from the chain, because we actually don't change the past. We cannot modify the information that is already stored in the blockchain, but we can add more information in the blockchain. But how do we add information in the blockchain is by executing transaction in the blockchain and writing into the block. But executing a transaction and writing into the block requires us to have control to the address or to the account that uh, we want to write the transaction with. In this case, your blockchain, I mean your wallet is hijacked, and then you forgot your private key. That means the asset that you used to have is already in the possession of someone else, and this other person has their own private key. This other person has their own address, and as long as we don't have the access to that account, it is impossible for us to send back the asset to our wallet, to our address. So it is impossible, basically, in a sense, to recover our account by hijacking the chain. And it is also not advisable to use an already exposed account, because once we recover an account or maybe send the asset back to us, the hacker can just easily send the asset back to them again, because they already have access to the private key. So that's the importance of private key, because once you already lose your private key, this private key will be able to modify or access any kind of asset that you have in your account. Hopefully that answers your question here, and I'm going to move on to the other one. You mentioned that blockchain can consume a lot of electricity. So how are blockchain platforms, especially those using POW, addressing this concern? Okay, so basically the blockchain that consumes a lot of electricity is the proof of work ones, and uh, electricity. I forgot the name. EDGA? No. Ethereum electricity usage. Not Ethereum. Bitcoin electricity usage. I'll just wait for the page to open. So basically, the uh, proof of work requires nodes that are the participant or the validators to do computing power work. And this computing power requires electricity definitely because it will make the CPU work at 100% capacity 24/7, validating the transactions. And to address this concern, there are a couple ways. First of all, some blockchains has already moved on from proof of work to some to more environmentally friendly consensus mechanisms such as proof of stake, and also IBFT and other basically other consensus mechanism that does not require computing power. But in terms of regulatory, I'm not sure how regulation can handle electricity usage. But because as long as this electricity is being used fairly and the people who mines pays for the electricity, I'm not sure that the electricity provider will be worried about that. Although I believe there are some movement or some pacts that already been proposed all across the globe on how to reduce of what we call the blockchain mine farm, or basically limits the usage of you know environmentally damaging electricity generation for blockchain mining. Some blockchain farms have moved on to you know they already have their own hydroelectricity generator, and then use this hydro generator to power up their blockchain farm. Not sure of the implementation here in Indonesia, but I've seen several of my friends who create a mining rig and mining farm. They is rent basically a ruko to a mining farm, but this is very costly, and they need to also provide the electricity, they need to provide the cooling, the air conditioner, they need to provide the internet and everything else, which is very costly for them to do. I believe they still want to do that because this kind of activity allows them to receive the incentive in form of crypto itself. So that is an incentive for them to do that. Not sure about the connection here. Yep. I like to refer to the study from Digi Economist here because how big the consumption of proof of work here. This is how big the impact to our nature. The carbon footprint is already very huge. The electrical energy is very huge. The waste and also the fresh water consumption. And one Bitcoin transaction, it emits this much of carbon footprint, electrical energy, electric waste, and the consumption of fresh water. And if we compare it, Bitcoin is already using more electricity than Poland, Egypt, Malaysia, and some other countries. This is relative to several countries here. And yeah, definitely moving to proof of stake is the way forward. But for as long as Bitcoin still lives in proof of work, it's still going to have miners who wants to receive the reward from Bitcoin, and it's still going to damage our environment. There are alternatives here. First of all, moving from proof of work to proof of stake, and yeah, so make sure that it's not going to be that you know, not going to be that damaging to our environment. It used to have the Ethereum energy consumption index when it was still in proof of work, but I haven't yet seen the impact when after it's moved to proof of stake. But as far as I understand here, it has already reduced the electrical energy requirement by 99.84% by changing the production method. You can see the cliff here. It was rising very rapidly, but after the to proof very friendly. And this one is Dogecoin. I believe this is the coin that's endorsed by Elon Musk. It's also very high. Okay, now the third question, is there a limitation on what smart contract can process? So basically, I've mentioned smart contract is Turing complete. That means Turing complete is it is actually it allows people to Turing complete means that it but the limitation here is not about uh, enough logic that smart contract can access. And you can imagine any kind of logic and you can implement it in smart contracts. So actually there is no limit in terms of the logic, but the limitation itself comes from the size of the execution of a function or when deploying this logic to the blockchain because it requires gas and this gas usually is limited at 30 million and it is also limited by the block size as well. And if the gas is already higher than 30 million, usually it will block the execution of the smart contract. And also, if the smart contract size is bigger than the block size, definitely it's not going to fit, and the smart contract will fail. Now, I think we already have completed our lecture. I'm still going to accept one more question, or maybe if you have any question, please write down your questions in the Slido. Otherwise, I'm going to have a little quiz here. Okay. It will be an open task. And how to... All right. Yep. Yeah, this is an open question, so you guys can answer this. So to motivate you a little bit, I'm going to just yeah, basically you can create you can answer this. Maybe if I want, I can just share you a little crypto probably. Is it possible to answer this? Are you able to answer this? I'll just try to answer it on my phone. Nope, there's no answer. Is they able to answer this? Okay. These are very good answers. Already understand the concept of smart contract. Okay, I'll create another question here. Technology that allows you to transact without third party. You can create it in the Mix IDE. Thank you very much. Uh, it's quite accurate. So there's another one that I wanna share with you guys. Uh, okay. Oh yeah, another one. Okay. There's also another one. Just drop your Ethereum address. If you don't know how to create an Ethereum address, first you need to download MetaMask. Yeah, download MetaMask and also try it yourself. And I'll send some to the first one that drops your Ethereum address here. Let's see how much I have. I'll send 10 USD, I think. Yep, our lucky winner. We already have one. Uh, okay. Yeah, I'll send 0.0038 Ethereum, which is about 10 US dollars. Okay, confirm it. Well, this is actually an actual live transaction, and it actually costs me cost me some money. But yeah, for the sake of showing you guys how transaction in blockchain works, so this is how it works. It's live on the Block Explorer. And this is the transaction hash that just happened 9 seconds ago, transferring $10 from this account to this account. This one is the account that I have, and this one is the account that this other person has. Yeah, this is the transaction that happens. Okay. I think that's all from me. I believe we have already covered everything. We still have 7 minutes. If you have any other question, please drop your question here in the in Slido. There's a question that says, why Ethereum are expensive gas fee? So Ethereum works, I mean, sending Ethereum requires you to have Ether. And the cost of sending a transaction, it depends of the complexity of the function that you want to share, that you want to do. If it is just simple Ethereum transaction, for example, you send an Ether to an address, it only requires very minimal Ether. But if it is complex, such as swapping an Ether to another token, or maybe swapping a token to another token, it's going to vary, and it can be much more expensive than normal. But if you talk about the expensive gas fee related to our current fiat money, which is rupiah, it is because of the value of Ether itself is fluctuating. It can be very expensive. It can be less expensive depending on how much the price of the Ether right now in the market is. I believe right now the price of Ether is about 2,400, or maybe I can check it right now directly in Indodex. I'm not sponsored by anything, but yeah, it's about 40 million rupiah for the price of one Ether. And then the price of sending one Ether here is at 0.50, I think, $0.50 or about uh, 88,000 rupiah. So that's the factors. Those are the factors that affects the price of the transaction that happens in the network. Now, there's another question from Zaria. What makes Ethereum the most dominant network despite its high transaction fees compared to Solana, BNB, and ETC? First of all, they the market for some time. They're the first mover, and the market option is already big. But even though Ethereum is being, outpaced by other network in terms of adoption, some networks are seen as maybe they can call themselves like Ethereum killer. But eventually, a lot of these networks circle back to Ethereum, and then they go back to Ethereum as the uh basically as the de facto uh blockchain platform or blockchain network that you use to deploy this decentralized application. Um, a lot of users have moved to Solana, but mainly it is because of the community that is being grown in the Solana ecosystem, and it is more relatable to the newer users, such as there are a lot of meme related coins in Solana. A lot of people who wants to go to blockchain just for the memes and for fun, they see Solana as the platform that embraces this culture very tightly. But when people want to do a lot of stuff that is more related to financial and more serious stuff, and a lot of like swapping USDT and everything, uh, some of the platforms are more popular. For example, for USDT stablecoins, there is the Tron network that is more popular rather than using the Ethereum. But for a lot of DeFi, decentralized finance use cases, Ethereum is a lot more popular because it is already well connected to a lot of exchanges, and it is more liquid for people to just swap or just move their asset from this network back to the crypto exchanges. Um, and then there is also not only that, there's also NFT. Some of the NFTs are now live in layer two or even um, non non-related blockchain networks than Ethereum, and it's thriving there. But when people want to buy this NFT, they need first network. Sometimes it's very time consuming, and it's such a hassle for them to maintain different networks for their wallet. So they just stick back to using Ethereum as the main basically the main blockchain for them. Hope that answers your question, and this is going to be my last one. What is the best practices or solutions for handling private keys and managing access control for Ethereum-based system in an enterprise environment? Uh, I need to have some clarification on enterprise environment, but I'm just going to answer with my capacity here. Basically, private keys are not meant to be stored in a server. It is meant to be stored in detached environment where these private keys should be ideally inside the offline wallet, where it is not um, where it is not uh, immediately connected to the network. It requires some physically, attaching this wallet into your device or into your computer for you to be able to interact and also use your crypto and interact with the blockchain platforms. In an enterprise environment, I believe if it is about private, I mean, not private blockchain network, but maybe enterprise blockchain network that is related to some, I don't know, blockchain consortium. There are some techniques to store this private key in a trusted environment. There are some like basically key vault, that this key vault is being stored inside a separate entity in your infrastructure. But eventually, this concept still requires the private key to be stored and the access to be moved to a more centralized, in a sense, control for the account, where it will kind of shift a little bit of the decentralization and also security to a certain degree, so that it is no longer that much private, it is no longer that much decentralized, and then people can have like your enterprise control, central governance into your private key, where it can be sometimes it can be beneficial for them, but sometimes it needs to have a balance of how we want to how to a certain degree that we want to have this key to be accessible by the central governance. Yeah, I think that's enough of the questions. I appreciate those who have asked these questions, and I believe this has been a very productive session where we study about Ethereum and blockchain in general, and also smart contract. I just want to thank everyone who has already participated in this session, and I'm going to give this session back to Saskia, who is leading this lecture. Thank you very much.
Yes, thank you so much, Mas Gilang. Maybe we can finish our meeting here.
Yeah,